doing a mini stream just to check my setup. I moved recently and not everything's set up, so this is not going to be quite as good. I can't find my microphone. It's in some box somewhere. And I just want to see if I can get everything to work. So today, let me just edit my stream title. Kotlin Heap data structure. Okay. So I'm working on a interview prep presentation on heaps. So I'd like to do a quick implementation of a heap. I've got a lot of it done, and I just need to find a bug. So you can see here, there's a comment that says there is a bug here, and I need to debug and see what's going on. Now I know that the bug is somewhere in here, or the swap, something like that. So I need to just find the place where I need to do a check. And I'll just go through, explain it, and then see if I can debug. And if all of that works out and I want to check the stream to make sure it's working okay, that's really what I'm here to do. So I'm not necessarily going to be streaming for hours today, maybe 30 minutes, see how far I get, and then check the stream quality afterwards. And I was streaming on Twitch, but I don't particularly want to stream on Twitch anymore. No reason outside of, well, actually the main reason is the video quality of the Twitch stream when I upload it to YouTube is pretty terrible, but the video quality when I'm streaming on YouTube is much better. Anyway, and I don't have to do as much work uploading. Okay, I'm going to start off talking about heaps since go back to IntelliJ. Okay, so I have this heap, and what it is it stores prioritized objects. In this case, it's integers. And let's make sure you can actually see it. Yeah, you can see that. You can have either a min heap or a max heap, but then when you start using non-integers, and what kind of heap is it? The idea is you have a tree-like structure underlying, and at the top of the root of the tree is your highest priority item. So find min is going to find the minimum item in a min heap, so give me the smallest integer. Find in this case means return it but don't remove it. Get min is give me the minimum item and return it and remove it. Insert is insert a new item, and then you can check if it's empty. So these are the methods that you have on a heap, and it is kind of, you can use priority queues. So I have my min int priority queue interface that I'm going to implement, and this is kind of, if you are doing interview practice questions, this is the interview practice question you'd see. Implement priority queue, and you'd probably get something like implement a priority queue where all operations are log n or better. So then how do you implement that? You implement that as a heap. That's one option if you want to have log n. got my heap as an array. So you have your heap interface, or your heap interface implemented. Your backing data structure for it is an array. It's efficient. So I'm writing in Kotlin. I've initialized an array with -1s. There's different ways to implement this. This implementation is kind of a toy implementation just to show how it works. So in this case, I'm initializing everything to -1, but you can't have any integers. You always have to have positive integers, otherwise it's going to mess something up. So -1 indicates that something's empty. Not a big deal. You could probably still use this implementation to have negative integers as well. And then the idea is you allocate an array, and that's the memory allocated for the heap. And you have to keep track of how many pieces, how many items are in there. So you have the size of the heap, so the number of elements in the array that's been allocated for some size, and that's where it's kept. When you want to find the minimum, it's going to be at the root. So that's the easiest one. Just return whatever's at the 0th. So that's pretty quick. When you want to get the minimum, it becomes more complicated. And what you end up doing is the minimum is at 0. So that's great. If there's nothing else in there, then you return min. So if in this case, if it's actually empty, it's going to return -1. Sure. So I'm deciding if nothing's available, return -1. You can change your implementation if you want. If you want to throw an exception or no, whatever. Okay. Yeah, I could have actually made these nulls, but then I'm not going to worry about that right now. So once I've got the item, I need to remove that item. So the way you do that is you swap it with the last item in the array. So you get the last item in the array and you say this is now the new root. And you decrement the size, and so I set the last element to empty again, -1, and you decrement the size. So now we have a less than a 1 item shorter array, and you now have an item at the root that may not meet the heap property. So you want to check, okay, if the root node doesn't meet the heap property, then swap down a path to try to make it meet the property. Now I'm not really explaining this as thoroughly as I would in the presentation because, again, this is me testing it out. So as I'm traversing the tree downwards, I have my current node, and then I have the left child. And the idea is I'm going to swap with the left child if the left child is less than the current one. So maintaining the heap property for each node, the children are greater than the node that you're looking at. So the left child is always going to be present if there are any children. So you may have a left child but no right child, because I'm going left to right. So if there's a left child, check it. If not, don't check it. So my bug is that I am not, I think what I need to do is left is greater than -1. So I think this is what I need to do, but I'll show you the bug. Okay. So I'll put, I've got a breakpoint there, and I've got my unit tests. My unit tests are checking that the right numbers are returned on each step. So I insert a bunch of items, 5, 4, 3, 2, 1, and then I check find min is the minimum, and then I keep popping to make sure that it pops in the right order. So you'll notice here that I insert them with the biggest one first, and then I expect them to pop with the smallest one. And so this is a test case. The other one is the inverse of it. I also have test cases where it just inserts a bunch of other numbers. This one is more to test that it resizes correctly, and that's a whole other aspect. Oh, okay. When insert task size, then increase size. Okay, that's fine. New test case. Right. So the problem here is this test is failing. So if I run this, something funny is going to happen where as I start getting down to the last items in the heap, it's returning the wrong values. So I need to sort that out. So I'll walk through, show you what's happening, and then I will correct it, hopefully. and it's starting cold. Okay, so we see this failing test. It says the actual was -1, but I expected 4. So here, as I'm getting to the last 2, 3 items in the heap, something funny is happening. So now I can step through and debug this and see what's going on with the heap. Now, this can be a little hard to see. So the heap here is an array. So I have 1, 2, 4, 5, 3. And that's not exactly the easiest to read. Let me resize all of these windows so that it's not such a problem to see it. Okay. That should be fine for now. Oh, not really what I want. I haven't, so this is what I mean. I'm trying to make sure my setup kind of works. Okay. Okay, I know exactly what that is. It's really worth doing the exercise to convert a tree into an array and back and forth, because this is one of the best ways to do better on tree questions. So if you struggle with tree questions, implement a heap. Okay, so now we're looking at this, and I have to get used to YouTube. So now we're looking at this, and we have this array. So this is the root 1. 1 has children 2 and 4, and then there's children 5 and 3 on 4. So actually, I'm going to copy this slide and show you